Hello, good evening, all. Uh,
Good evening,
so,
ma'am.
Good evening. Today is all with us for week 4. So, for that, you will have to go to joinpd.com. So, you will be given us, and when you go to joinpd.com, you'll have to enter a code. So, the code here you can see on the screen, WPFT So, you start it, and then we can start the session. So all of you who are in the session, please go to joinpd.com and use this code. So I will wait for 1 minute. So I will let you people to join.
Ma'am, can you give links to student in the chat box?
Yeah, okay. So what link you want?
In your screen, in the bottom, it is given give student a link. Can you copy it and send it in the chat box so that we can easily enter?
Okay, fine.
Excuse me.
Yeah.
For week 2 and week 3, the Solvit instructor slides are still is not uploaded in the portal.
It is uploaded on the portal. You'll have to go to self-paced peer deck activity.
Okay.
There you will find the slides.
Okay. Thank you.
Okay. So I see some 75 people here, but 26 are only connected. Please join, go to join PD and use the password. Okay, so shall we start? Do you want to join? So, okay, if somebody is late, they can again go to joinpd.com and use this code to start. Okay. Okay, so your first question here is the CDF of a random variable x is fx of x is 1 minus sigma minus 7x. And you have to find, okay, who's there? Please mute. Yeah. So the CDF of the random variable is given to you. And now you have to find the probability such that x is less than equal to 10. I hope the question is clear. So I will just wait for 2-3 minutes, then we can proceed with the solution.
Just writing the option number is fine, right? Or do we need to write the
No,
number?
just writing the option number is fine.
This is first question, sir.
Sorry.
This is first question, ma'am.
Yeah, this is first question. So there are many participants here, but only 52 has logged into the peer tech. So if you haven't joined it, go to joinbd.com and use the code that you can see on the right corner of the screen. Yeah. Is there any doubt in this question, or it is clear? Responses. So So most of the people have answered option B, but I can see many A's also. Okay. So can somebody tell me how they got option A?
Ma'am, when we thought it like p one minus
Probability.
probability of x is greater than or equal to 10.
Sorry, I didn't get you.
Ma'am, it
Huh?
is like probability of x is
Huh?
less than equal to 10.
Huh?
Then we write it like 1 minus pro p
Hmm.
bracket में x greater than or equal to 10.
Okay.
Okay, then 1 minus, then
Huh?
in our fxx it is
Hmm.
given that x is greater than or equal to 0, then it is 1 minus e to the power minus 7x.
Okay.
Then
So
we
there. Okay. So there you went wrong. So see, it is what is x less than equal to 10? What is the formula of fx of x?
what is,
What
ma'am?
what is the formula for fx of x? If I ask you write the CDF of a random variable x, what will you write?
Ma'am,
Like in general formula.
in general for formula it is, ma'am, fx.
No, no, no. Like if I write fx this capital fx of x, so this is equal to what?
Yeah, it's probability of x less than or equal to 10.
Yeah,
Like,
right. No.
yeah,
So
I also
fx
did
of
the
x
A.
is so
I also did
fx
the
of
mistake.
yeah. So fx of x is probability x less than equal to x. So in the question, it is as probability x less than equal to 10. So here 10 is your x. Okay. And
Yes,
how is
ma'am.
it defined? Like for so this, if you observe it carefully, like this is the CDF for your exponential distribution, right?
Yes, ma'am.
So for
Yes, ma'am.
x positive, for any x positive, your CDF of the random variable x will be defined as 1 minus e to the power minus 7x.
Yes,
So
ma'am.
in this case, your 10 is greater than 0, right? So this is nothing but fx of 10. So this we can write it as p of x less than equal to 10. This we can write it as fx of 10.
Okay, yes, ma'am.
Okay. So, uh,
Option B.
option B will be correct answer.
Option A.
Option B.
B is
B.
correct. No?
Yeah,
Yes.
see,
B is correct
you
answer.
can see the solution here.
Yes, ma'am.
Yeah. So fx of 10 we can write it as fx of px less than equal to 10. We can write it as fx of 10, right? So fx of x is already defined, and so the correct answer will be 1 minus e to the power minus 70. Is it clear?
Yes, ma'am. Thank you, ma'am.
Okay. So from the first question itself, like this is the
Ma'am,
serious that is, yeah.
I mean the answer, when we put answer, more than one option is also their option how to enter in the jointpd.com.
If we have more
It
than
is,
one,
it is required to enter this one, enter key,
uh,
or just type B.
you can just type B.
Okay.
Yeah. If there are multiple answers, you can type B. Let's say the answer was B and C. So
Okay.
you could
Then
have typed B comma C.
okay.
Okay.
Okay. That's
Yeah.
why after entering it is going down and it is not showing. Okay.
Okay. So somebody has asked, can we solve it like fx of 10 minus fx of infinity minus infinity? Okay. Why do you want to do fx of 10 minus fx of minus infinity? Abhilasha?
Can we get by differentiating also, ma'am?
Sorry.
Because the CT, we can differentiate the CDF and then we can put the value. Is it also the way?
Yeah, that is also the way.
Uh, First we differentiate, then put the value, right?
Yeah, so you had to find what? You had to find the
Yeah,
effects of.
please, how to differentiate and get the same.
Okay. Pen is not working. Otherwise, I could have written here.
Okay.
You can try it out. Okay. Maybe I can show you at pen.
How
Okay,
will it
okay.
come by
After differentiating,
It will not come by differentiating.
no. After
No,
differentiating, you have
see.
to integrate it again. So why to go
No,
in that
no.
way?
See. You have to find probability x less than equal to 10. So
Yeah.
you will have to first find, if you want to use the integration, then first you'll have to find small fx of x. So this is your CDF, not the PDF.
Yeah,
So whenever
CDF.
you find the probability, you will have to integrate the PDF. So fx is given. So if you differentiate fx,
Then we will
then you
get
will
the
get
equation function
then
for the
then
PDF.
you will get PDF.
Yeah.
Then that PDF you will have to integrate from minus infinity to 10.
Okay.
Yeah, that is a cumbersome method. Why to go that way?
Yeah.
Since CDF
That
is given.
is what that
No,
is what
that
I
is
was saying.
cumbersome method. But in case of other cases where the equation function is not directly executable, then that
No,
can be
if
used.
CDF is given, then you can always find the
No,
value.
like somebody,
Or-
okay. Yeah, it is easier this way because it is already, you can see fx px less than equal to x. So this is direct fx of x. So it is much easy. But
Yeah, it
let's
is
say
easy.
somebody doesn't know how to do it, and but if you know that CDF is like you can find the PDF just by differentiating and all. So like it is more lengthy. I mean that process.
That will be lengthy.
Yeah. Some cases
Got
that
it.
will be easier. Yeah. Okay.
Nikhil,
Okay,
I'm just
so
trying to recall this particular connect that was there between CDF and this probability. Do you mind
okay,
explaining in quickly? I mean,
okay.
we just we have substituted the value, but I'm not able to recall the connect. If you don't mind,
What value you have substituted?
we have substituted 10, and we have got 1 minus e raised to power minus 70 as the answer.
Yeah, right. So what is the doubt?
So the connect between probability and the CDF.
Okay. So if I say, okay, is it okay if I just say, because my
Yeah, I'll
pen is
try to
not working.
understand. Yeah, sure.
So let's say here you have to find probability x less than equal to 10. So in this case, you will have to integrate, and this in integration, you will do the integration of PDF, right? So every time you do the integration of PDF, and what should be the limit? Since x is less than equal to 10, so x can go from minus infinity to 10,
10.
right? But your x is like from minus infinity to 0, it is going to be defined as 0.
Okay,
So
got it.
basically you will have to go from 0 to 10.
Got it. Yeah.
Yeah.
So with I mean, basically, we are trying to find the area with integration if we find the PDF
Yes.
from CDF, right? I
Yes.
got it. Okay,
Yeah.
thank you.
And
Got it.
here the
Thanks.
area is 0 to 10. for the integration.
Limit is 0 to 10, not
Yeah,
8.
limit.
Yeah.
Limit is a support.
Yeah.
Area calculated on the support of 0 to 10.
Yes, right.
Right.
Okay, so let's move to the next question.
Yes.
So it is a continuation from the previous one. So the same CDF is there, and now you have to find the value of minus
just
2.
ma'am, let us write the PDF first because we did not write. Please show the question number 1, please.
Yeah, right. So you must have written for question number 1. So use that.
No, not written directly. Yeah.
Okay.
Okay, thank you.
Okay.
Let us go.
So now you have to find the value of probability where x lies between minus 2 to 4. So, is it done?
Yes,
Yes, ma'am.
47 responses. Okay, so again, it is multiple answers A and B. Okay. So, can somebody explain how they got option A?
ma'am.
Yeah, it is less than 0, we'll consider it as 0. Up to probability of x less than or equals to 4 is equals to.
Yeah. Right. And how do you get option B? Anybody can. Anybody?
Ma'am, it is. I think it is option A.
Yes, it is option A.
Yes, ma'am. Right answer should be option A.
Yeah.
Yes,
Okay,
ma'am.
so
So just we go p x equal to 0 minus p x equal to minus 2. Then p x equal to minus 2 is the we get
you
0 here.
you can just directly do it here. P like fx like CDF of 4 minus CDF of minus 2.
Yes, ma'am.
Right.
Yes, ma'am.
Okay, so
Ma'am, then my minus 2, CD of minus 2, what will be the CD of minus 2?
Yeah. So see, you have x lying between minus 2 to 4, right? This is the question that was asked. So you know that probability x lying between A to B, that can be written as fx of B minus fx of A. Correct? So fx of x is already defined in your question. That is 1 minus e to the power minus 7x, right? And but that is for x greater than equal to 0. If x is less than 0, you are going to put 0. So that is why fx of minus 2 is 0, and your correct answer is 1 minus e to the power minus 28. Is it clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, yeah. Please mute. Yeah. So we move to the next question. Okay, so here your x is a continuous random variable. Now here the PDF is given to you. So PDF is defined as k x square plus 4, where x lies between 0 to 1. And now you have to find the value of k. So you may need this integration formula. So I have put it here. So yeah, you can write your responses. Okay, shall we move?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. So all of you know how to find the value of k?
Yes, ma'am. We just integrate it and it is equal to 1 for the limit 0 to 1.
Right. So what value of k you got?
3 by 13.
3 by 13.
Yes, ma'am. 3 by 13.
3 by 13.
Okay. So many people have got negative answers. How did you get negative answers?
No, ma'am.
No, ma'am. It is 3 by
3607.
13.
So many people have answered it negative.
Integration formula upper limit minus lower limit.
Yeah, right. So integration formula is
Maximum.
given here. Yeah. Okay.
So here, how CDF is equal to 1?
You have not CDF, PDF.
Oh, if we integrate PDF, we'll get CDF, right?
If we integrate PDF, you will get CDF,
CDF.
right?
So why it is equal to 1?
But what is the formula of fx CDF? You have to integrate, but integration is from like minus infinity to x.
Yes, ma'am.
Minus infinity to x, right? So
Yes.
while starting this week, you must have seen the properties of PDF. What all properties PDF satisfies?
PDF, it's sum of minus infinity to plus infinity. It should be equal to 1.
Yeah. So there in infinity to minus infinity, it's basically the range. I mean, the support where it is non-zero. In that, it is equal to 1.
Yes, ma'am. So CDF equal to 1 between 0 to 1, right?
It is not CDF.
No, if we integrate it, we'll get CDF. Right?
Yeah, but what is the limit of integration there?
There's minus infinity to x.
X, right? So
Yeah.
that if you integrate, will you get 1?
No, minus infinity to x. If we integrate, we will not get 1.
Yeah. So if you look at the
In terms of x.
So if you look at the definition of CDF, what a PDF, what does it say? Like it is a function from real number to real number, and it should satisfy few properties, right? So fx should be greater than equal to 0. That is the first property. Second is it should be piecewise continuous. So we'll not go in that part. And third is the integration limit over the whole range. Okay, that should be equal to 1. So in this case, your limit, like overall limit, is given from 0 to 1. Otherwise, it is 0. Even if you take, let's say, minus infinity to infinity, so that should be equal to 1, right? So till from minus infinity to 0, your function is defined as 0. But from 0 to 1, your function is defined as k into x squared plus 4. And again, from 1 to infinity, it is defined as 0. Right?
Here we are using the property that area under PDF is 1.
Yes, right. Same thing. So PDF from minus infinity to infinity should be equal to 1. And now since in the range minus infinity to 0 and 1 to infinity, your fx is defined as 0. So we'll just integrate the function from 0 to 1. Right? So if you integrate, you will get k equals 3 by 13. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. We can move forward.
Okay. So from the same question, you have now you have to find the value of probability such that x lies between 0 to half. You have to use the same PDF. So you can write down the PDF formula. sorry, PDF. And you have to find probability X lying between 0 to half.
Hello, ma'am.
Yes.
Ma'am, I have one query here that in this case, the probability that x is equal to x is greater than 0 and less than 1 by 2. Since this is already mentioned that this is a PDF, so we don't have any problem. We integrate it over 0 to 1 by 2. But sometimes when it's just the distribution that is given, like x distribution over exponential, and then such probability has been asked. So sometimes I tend to use this formula that f of 1 by 2 minus f of 0, treating it as continuous and CDF. So I don't understand how to differentiate those two. Like if it is mentioned PDF, then it's okay. But somewhere if it's not mentioned.
Okay, so both ways you can solve it, right? Like if the distribution is explicitly mentioned that your random variable x is exponential distributed, or it is geometric, or Poisson, or something like uniform. So in that case, you already know the distribution, both PDF and CDF, that is known to you. So there you can directly use. So if a question like this comes, like find the probability that x lies between A to B, then in that case, it is if the CDF is if the CDF is known to you, then in that case that becomes easier to solve. Like you can directly do fx of like CDF of 1 by 2 minus CDF of 0. But if the CDF is not known to you, let's say the PDF is known to you.
So if it is not mentioned that this is a PDF, it's just a graph that has been, it's just the function that has been given to us, and it, like we can only identify it by small x, f of small f of x or capital F of x. Suppose
No,
it's not
in the question it will be mentioned. Like if any function is given to you, so it should be mentioned whether the function that is the distribution that is given to you is the PDF or the CDF function.
Okay, so it will be like in the lectures that sir is the questions that sir is solving. Sometimes it's just written that this is an exponential or geometric or binomial, and sir is then drawing the coming to the conclusion of that function. So
yeah, that's what. So for the known distribution like binomial, exponential, Poisson, so in that case we already know both the PDF and CDF. We already have it, so we can directly use it there.
but is there any difference if I integrate it over this or if I use the f of 1 by 2 because both are used for continuous, isn't it?
Okay, you mean CDF?
Ma'am, yes ma'am. Because if CDF is continuous, then it doesn't matter whether it is less than equal to 1 by 2 or
right. So what exactly is your doubt? Can you repeat?
I want to ask, like, suppose an exponential function has been given to us and such a probability is asked, like x is greater than something and less than something. So if it is mentioned that this is a PDF, so it's well known to me, I'll integrate it over something over 0 to a to b. But sometimes when it's not mentioned, like it's just a function of an exponential or a binomial, and then I have been asked to solve such a question, probability of x is greater than.
That's what I'm saying. Like in the question, it will be mentioned, like whether the function that is given to you is PDF or the CDF.
Okay, ma'am. Okay, ma'am. But but is there any difference if I use f of half minus f of 0 or I integrate it? Is there any difference because both are for continuous?
So
yeah, if CDF is given, then I think you can use that.
If you have to integrate, then in that case you will integrate the PDF, not the CDF. That you'll have to take care of. Don't integrate the CDF function, integrate the PDF function.
Okay, ma'am. Okay. Thank you, ma'am.
Yeah. So here we have received. Okay. So what answer you got?
0.47.
24 by 49.
0.47.
0.47. Okay.
0.47.
Okay. So let's see the solution. So yeah, so K value we had already found in the previous question. So K is coming out to be 3 upon 13. Now you have to find the probability such that x lies between 0 to half. So you will have to integrate and take the limit from 0 to half. So just integrate the function. I hope you all know how to do the basic integration and just substitute the limits. So once you solve it, you will get 49 by 104.
As well as since the CDF was also done in the previous exercise, that also can be used, right? F of half minus f of 0.
But that PDF, that CDF was not the CDF for this function.
No, when we evaluated the value of K, that time around the intermediate step anyways was, I have to go through CDF, right? Integration of CDF. While doing that, and I equated it with 1.
Okay.
So that CDF also can be used. It yields the same point. It gives you the same result.
Okay. So what was that?
So here it was like K x cube by 3 plus 4x. That was the CDF.
Yeah. So the integration limit. Yeah. Right. This will be the CDF.
Yeah. So there in itself, if just replace K value.
If you just replace there, yeah, you should get the answer.
Yeah, it's the same approach. Either way, it can
put the K value and just substitute. Yeah.
Limits also has to be changed.
Yes, limit has to be changed from 0 to half.
But in your solution, please show the answer first.
This is your answer.
Answer,
This one.
just a minute.
Ma'am, okay, this is 0 to half. Okay.
Yeah.
Okay, 0 to half only. So
Yeah.
minus infinity to 0 is always 0, right?
Minus infinity to 0. Yeah, it was 0.
It is 0 because otherwise, otherwise it is 0, and greater than 1 by 1 is also 0. So,
Right.
yeah.
So this part is clear.
Just
Yes,
one
ma'am.
doubt, ma'am, that we are not considering x within the any of them, that not equal to any of the value, either 0 or half.
Sorry.
We are not considering the value of x not equal to not inclusive with 0 and nor with half. So shouldn't we consider either of them?
Okay, so your doubt is in the question it is asked like 0 and half is non-exclusive.
Yes, yes, yes.
So it's not x less than equal to half. That's the question. But since it's a continuous variable,
random variable. Yeah, so it doesn't matter because at those specific point it is going to be 0.
so when it is a discrete random variable, that time around it is important.
Yeah,
Continuous
that
random
time it
variable,
matters.
yeah, it's like that an epsilon will be it's going to limit factor. It's very
Yes.
minuscule factor that it doesn't matter. At specific point, anyways, we will not get any value.
Yeah, right.
So we'll consider the both of the limits because both are exclusive only.
Because x is a continuous random variable here.
Yeah, it is continuous, but isn't it like that our limits will change from 0 point something h plus h dash to half
No,
minus something h dash?
no. So because for in case of continuous random variable, at those point will be 0. So that difference is very small. What
It is
Ranjit
defined.
has
It is
explained.
defined on a support.
Very
It is
small,
defined on a
like some
support.
epsilon. Yeah, some very small epsilon. So as you and that difference is very small, so it won't matter. I mean, the area will be very less.
In all practical purpose, the moment it comes to an integration, whether it is equal to or not equal to doesn't matter in practical purpose. We can take it that way.
Yeah.
Okay, thank you.
For integration.
Yeah, right.
Ma'am, in joinpd.com, while entering the number, whether we can enter 49 upon 104 also, or we have to put the decimal number on.
49. I think you can. Wait. Let me check.
You can't put it only alpha, only number.
It is number, right? Only decimal.
Only number. We have to put the number only, right?
Yeah.
Yes.
That's why it was not taken. Yeah. Okay, ma'am.
Okay. So let's move to the next question. Yeah. So here you have again a continuous random variable, and the PDF is defined as 3x square for x lying between 0 to 1. Otherwise, it is 0. And now you have to find probability such that for given x greater than 1 by 4, you have to find the probability for x less than equal to 1 by 2.
Ma'am, the K value will be using the previous question?
Here there is no K.
Okay.
Yeah.
Why did I copy that?
Now herein it is given, how do I find it? Find probability x less than equal to 1 given that, or is like, or?
Given. Conditioned
Given
on,
that it is.
conditioned on x greater than 1/4.
Okay.
Yeah. Okay. Can somebody tell me the answer?
0.11.
0.11, yes. Or 7/63.
Okay. Let's see the solution. Okay. So we had to find the probability x less than equal to 1/2 given x equals x greater than 1/4. So here we'll have to use the conditional probability formula. So x less than equal to 1/2 is a 1 even, x greater than 1/4 is a 1 even. So if you write it, it will come out as probability x less than equal to 1/2 and x greater than 1/4 given x greater than 1/4, that will go in the denominator part. Now given now probability that x is less than equal to half and x is greater than 1/4 is nothing but your x is lying between 1/4 to 1/2. So the definition, like the PDF is already given to us, that is 3x square. So for x lying between 0 to 1, it is given as 3x square. So you will have to just integrate the PDF from 1/4 to 1/2 in the numerator and integrate from 1/4 to 1 in the denominator part. Right. So once you do it, you will get your answer as 7/63.
Yes, ma'am.
Yeah. This is clear
Yeah.
to everyone.
Yes, ma'am.
Basically, we have to decide the conditional functions. What is the support for the probability, right?
Yeah.
Right. The basic question is that, right? Now, other
Like
things.
you should know, like the conditional. The question asks you. It is a conditional
Sometimes,
probability
yeah.
formula.
Sometimes it is in between. X is in between minus 1/2 and 1/4. Sometimes it is only greater than 1/2. Sometimes it is right now.
Yeah, right. So you will have to use the formula and just check the limits properly. That's it.
Limit.
Yeah.
The basic thing is required to check the limit.
Hmm.
The error prone zone is this limit, right?
Yeah, right.
Yeah. Okay. Thank you.
Okay. So this is your next question. Now you have the same PDF from the previous one. Now you will define another random variable y that is given as x cube. So how will you find the PDF of y?
Can you show us the options?
Yes. So all of you written the question. Please write the question. So these are the options you will get.
Also, my question.
Yeah, okay. First, I will stay at the question part.
Just.
Yeah. Please write it down. Yeah.
Ma'am, show the question just for a minute.
Okay. You can take a screenshot.
Yeah.
So this PDF is the same as the previous question, and just your new random variable y is given as x cube, and you have to find the PDF of the random variable y.
It's 20 hours.
Okay, so I have received only 43 responses. Anybody else who wants to answer? So as you could see, most of you have answered either B or A. Do you need more time, or should I discuss the solution?
Let's discuss the solution.
Maybe the solution and the theory there.
Yes, we have discussed the
Yeah.
solution.
Okay, all right. So the PDF was the same as the previous one, that is fx of x, and now we have to find the PDF of x cube. So this is our function of random variable, right? So if you what is the support of x here?
0 to 1.
0 to 1.
0 to 1, right? So what is the monotonic, when can we use the monotonic differentiable function theorem? Can somebody tell me the conditions? When we use it?
Differential, continuous, and differentiable within the range.
Okay.
It should be increasing or decreasing something.
Yes.
Yeah. So
It's a monotonic function.
yeah. So the basic thing is like your range should be like your x should sorry, the function y here should be monotonic in the support of x. So if that happens, then you can write your fy of y to be 1 upon g dash of g inverse y, and in the numerator part it should be fx of g inverse y. So the derivation part, like how we got this, right now it is not possible to.
This
Yeah.
definition is yeah.
Okay, so
This
maybe
this
that can be
confusing.
taken in the revision session. I'm not able to write like.
Okay, just give a first principle.
Yeah, so you will have to start now. See, you have to find the PDF of the random variable y. So what you can do is you can start with the CDF of y. So if you write fy of y, that is going to be probability y less than equal to y. Then again y is x cube less than equal to y.
Pen
You'll
is
have
not
to.
working. Your pen is not working.
Yeah, my pen is not. So we'll take the derivation in the revision session. There is revision session next week. So then that time we can use. So even if you don't know the derivation, it is all right. So you should just know for now that in case your random variable like the function gx, if that is monotonic in the support, so in this case it is x cube. If you draw the graph of x cube in the 0 to 1 range, it is going to be monotonic, right? Is it monotonic increasing or decreasing? X cube.
Increasing.
It is increasing.
Right?
Increasing.
So yeah, so it is increasing in the support 0 to 1. So in that case we can differentiate it, and we can find, you can use the formula to get the PDF of y.
We have to draw the graph also, ma'am.
Yeah, like to check whether it is like, if you don't know like whether, if you're not aware of the graph of x cube, we can plot it and check whether it is increasing or decreasing or not increasing or not monotonic.
Either it is increasing or decreasing, then we can differentiate the y function.
Right.
Y function, right?
Yeah. Okay.
Nikita, can you explain the numerator part over here in the formula that we can use the formula? Therefore, we can use the formula. The numerator.
Yeah. Tell.
Yeah, the numerator, which is PDF of G inverse of Y. This is the portion where I'm getting stuck. Once we put G inverse of Y in fx.
You're right.
Yeah, so I was not able to solve this particular portion. That is the problem that is causing in the questions also. So
Okay.
G inverse of y over here is y under
To the
root
power
cube root of y.
cube root of
It
y.
is just express x in terms of y.
Yes, right. So
Right,
what,
ma'am?
G
yeah,
inverse of y is cube root of y, and then when we
yes,
put that in 3x square, right? That this is what we are basically doing.
yes, right. So in this case, your G inverse y is a cube root of y.
Cube
Okay.
root of y, right?
And what is your fx? It is 3x
3x
square.
square,
So
right?
let's say your y cube is x. Okay. So if you have to write your PDF in terms of, now in place of x, just substitute cube root of y. So what you will get? You will get 3 into y to the power, sorry, y 1 by cube root of y square, right?
Y 1 by 3, yeah, cube root of y square. Okay, so that would be 3
3
y
y
raised to power
power
2 by 3.
by
Ah,
3.
okay, yeah.
Right?
Okay. And then of course, then it is the derivative of G inverse of y.
Yeah. So
next.
Yeah. So till this part is clear.
Yeah, it is clear, ma'am. G dash x and G inverse y is clear.
Okay.
In numerator part, we are taking the mode value.
In denominator part.
Sorry, sir.
Yeah. So this is the
This
formula.
line, this line, ma'am, we know that in the range of 0 to 1, x cube is monotonic. So we can apply this function, the formula given in the lecture also.
Yeah, right. So we can use this formula.
Directly we can apply
directly use the
everywhere.
formula. Yeah.
Directly we can apply this everywhere.
Yes. Yes. If you know it is monotonic in the support.
Yeah, but the question will be always for the monotonic. If it is not monotonic, it will not define.
Yeah. Then in that, even in the lecture, you have seen such problems. If it is not monotonic,
is
how
the-
to, you'll have to go through the general procedure.
General table method.
Not table method, general method. You'll have to
Table finding the one by one. Trivial method of finding the probability.
Yeah, right. Right. So fx of G inverse of y, we got to be 3 into y to the power 2 by 3, and G dash was 3x square, right? So G dash of again this part y to the power 1 by 3, it is going to be 3 y to the power 2 by 3. So it is going to come as 1, right? Because both are coming out to be same, equal.
What's once more one?
Yeah.
G dash. The 3x square. 3x square.
G dash x is 3x square.
Yeah.
So if you take G dash of cube root of y, that is again going to be 3 into y to the power 2 by 3. So both numerator and denominator part is going to be same. So your Fy will come to be 1.
G dash of cube root of y.
And how is G dash of x defined? It is 3x square.
So 3 into y cube, y to the power 2 by 3.
Yeah, right.
And fx of G dash y is, that is also 3x square.
Right. So
fx is also 3x square and G dash is also 3x.
Right.
That's why it is 1.
So you will get 1. So now how to check the range? So for x equals to 0, since y is defined as y equals x cube, since x is 0, so y is again going to be 0. Now if you put x to be 1, y is also going to be 1. So your y is lying in the range 0 to 1.
Y is also lying 0 to 1.
Yeah, y is also lying between 0 to 1.
Yeah, you put the value of the answer. Then next lines after getting the fy of y is 1. Then therefore, okay, now we can put the value directly.
Yes.
0 to 1. Find
0
the
to 1.
integration, right?
Yeah.
Integrating fy with respect to y, right?
So fy of y is coming out to be 1, and the range is 0 to 1.
Fy of y with respect to dy. Integrate. We have to integrate.
Why do you have to integrate? I have asked you to find the PDF of y.
Okay, directly we can.
This
is PDF function. We can.
Yeah.
There is directly we can put the value of y. What was the question? To find the PDF function. Question? What was the question?
It was to find the PDF.
PDF.
Yeah.
Then answer is 1.
Answer is 1. Yeah.
Okay. PDF is something slightly confusing because we have
Nikita, can you go back one slide, please?
Yeah, right. Okay, so somebody had posted the solution in the general method. That also you can check. So this is by using the formula. So how will you find without using the formula? So somebody has shared the solution. So
Where
Vishal, yeah,
where?
in the chat box. Okay. So this question is fine. Should we move to the next question?
Yes, ma'am.
Okay. So this is the last question. Okay. It says the test scores of statistics portion in the qualified exam are normally distributed with a mean score of 46. If the standard deviation of the score is 15, then find approximately how many percentage of the scores are between 16 and 61. So this problem is for the normal distribution, and whatever values is needed to solve the problem, CDF values are given to you. So you can use it to calculate the answer. नहीं होता है। Okay, so I have only received 22 responses for this question. 23. Okay. Is this question clear? Like what to find?
Yes, ma'am.
Okay. All right. So what is the answer you are getting?
0.81859.
Yeah.
82.
So here you have to find the percent of scores. So you have to write the percentage. I can see many people have written within probabilities.
Yeah, we would have written it as 0.81, 0.818.
Ah, okay. So okay, I'll go to the solution part. So the question says the test scores are normally distributed with the mean score of 46. So your random variable here is the score obtained by students in the qualified exam. And it says it is normally distributed. Your distribution is normal where the mean score is 46 and the standard deviation is 15. Now you have to find like how many percent of scores are between 16 to 61. So what proportion of scores lies between 16 and 61? So basically you have to find probability that X lies, what is the probability that X lies between 16 to 61? So you will have to do the normalization here.
Ma'am, here a score is in percentage or the real score?
Where?
Percentage of a score is being considered.
Yeah, percentage of scores.
Percentage of score.
Huh. So that you can obtain from probability. So you have to find probability probability such that X lies between 16 to 61. So so in order to make it in the form of standard normal random variable, it is given that X is normal, but to get the answer, like if you don't make it into the standard normal form, then in that case, you will have to do the integration of the very complicated PDF. That is very difficult. So we'll make it into the standard normal form. We don't have any closed form for the like CDF form for normal distribution. So we make it the standard in the standard form, because those values are already available to us, so we can directly use it from there. So to make it in the standard normal form, what we do is we subtract the mean from the random variable and divide it by the standard deviation. Yeah. So from both the sides, you will have to subtract the numerator from, you have to subtract the value from the mean. So mean in this case is 46. So you're subtracting both sides by 46 and dividing by the standard deviation, that is 15. So your x minus 46 divided by 15, it will become the standard 0, 1, standard normal 0, 1. So that we represent using the capital Z. So this is the notation that we use for standard normal.
Which notation?
Z, capital Z.
Okay, capital Z
is the notation for standard normal distribution.
Okay.
So that standard normal distribution means normal, the distribution is normal with mean 0 and variance 1. Okay, so if you do that, if you make it in the standard normal form, you will get probability that Z lies between -2 to 1.
Means here x minus 46 upon 15 is equal to Z.
Yes, right.
Yeah.
So after, once you solve it, you will get probability Z lies between -2 to 1. So from there, you can directly write FZ of 1 minus FZ of
this
-2.
negative value will be counted. This negative value 16 minus 46 is negative. Probability of negative value.
It's a normal distribution's
normal.
negative value, Z
Yes.
being within this range.
Value of the Z is negative,
table,
not the probability, right?
The bell-shaped curve. The bell-shaped curve. Yeah.
Random variable is negative.
Yeah. So X is taking. Sorry, Z is taking.
X is taking negative value, but probability is not taking negative value, right?
No. Probability will not be negative.
Yeah.
So
here Z is taking negative value.
Yeah. So the values are already given to you in the question. So FZ of -2 is given, FZ of 1 is given, -1. So you can use these values from here and just substitute it. So you will get 0.81859. So this is approximately 81.8% of the scores that are between 16 and 61.
Z minus FZ of 1 minus FZ of -2. Then why all this value has been given? Z is equal to 0.5, 0.50. Why it is so many values has been given in the question?
Because we cannot just give you two values there.
Okay. If you make errors, then that value is also there, right?
Yeah.
Okay. Thank you.
Yeah. So is this question clear?
Yeah.
Yes, ma'am.
Okay.
This formula-based question, we have to understand the formula properly.
Yeah. Okay. So this was our last question.
Can we discuss one question from activity 4.8, fourth one?
Activity 4.8.
All questions done, ma'am.
All question is done. All the questions are done.
4.8.
Okay, just let me check. Can you tell the question number? 4.8 question number.
9th one, last one.
Okay.
The probability of PDF of random variable is.
Okay. So there you
Can you
have
please put it on screen, please, so that others also can see?
Okay. So here you have to find the expected value of x square. So what is the formula for expectation? What is the formula for expectation?
E of x.
No, that is the notation. I mean, how do you find the expectation?
X into probability of x, correct?
Yeah. So this here x is a continuous random variable. So in place of doing the summation, you will do the integration.
Integration x into fx.
That is the formula for expected value of x. But now here we have to find the expected value of x square. So that is going to be integral of x square times fx of x dx.
Integral of x square understood, multiplied by the corresponding probabilities have to come.
Yes.
The probabilities are coming by way of
probabilities are given to you.
Yeah, these are already given. So integral of x square into
fx of x.
Fx of x, yeah.
Dx.
First we have to find ex, and then we have to find e of x square, right?
No. You have to just find the expected value of x square. You don't have to find expected value of x.
The question is find the expected value of x square.
Yeah.
Directly we can find.
And third one, ma'am, in the same activity, third one, what we need to find? What is the notation for third?
Okay. So the probability density function
For
is given to
first
you.
one, for second one, we have to find the expected expectation.
So
third one, what we have to
if you will notice, this PDF is what? It is exponential distribution PDF. Lambda e to the power minus lambda x. Correct?
Yeah.
So expected value you can find because expectation, in this case, lambda is 1/4. So expected value will come out to be 4.
Yes.
Nikita, just one thing on the first question. The intervals would be?
Which question?
Yeah, just the first question. Sorry, scroll down a little. The question that he was asking before this.
The first
question number 9.
Okay.
Yeah. So over here, the intervals will be 0 to 1 and 1 to 2.
Yes, right.
Right. And that is how we will get the probability 2 minus x. I mean, multiplying by fx, that is what it is meant, right?
Yes, right.
Yeah.
Right.
Fine. Thank you.
Interval will not change, ma'am. Here.
No. So, okay. So in third question, you have to find the probability that time between calls exceeds the expected time.
So we have to find that x minus mu greater than x mu or what?
I mean, x is greater than mu, basically.
Or just x greater than mu.
Yeah, right.
Oh, then what will be the answer? X greater than mu in the sense?
1
so
minus probability of x less than mu.
1/4.
Can you solve
Right,
it?
x greater than 1/4. Or x greater than 4.
We have to first find out the expectations. Then we have to find the x greater than mu.
Yeah, right.
So x greater than.
Right, ma'am?
Yeah, right.
First find the expectations and then find the probability greater than that mu.
Try it out.
Yeah. Now, one question in the tutorial, solution is given, but some confusion is there in the tutorial 2, question number 2.
So yesterday's session, you guys didn't attend.
Yeah, attended.
You didn't ask the question.
No, so, but yesterday most of us didn't solve those questions.
Question is solved, but something.
Tell.
Question number 2. While solving, go to the solution. Some steps are.
Okay.
Here, question number 2. The solution PDF. Yeah. Go down.
Yeah.
Oh. Next para.
Okay.
Here. Can we do a step by step on the solutions? Yeah, because what I was doing here.
Okay.
First, yeah, please just explain without pen.
So
PDF of X is given, right?
The PDF of X is given. Okay.
Yes.
And Y is equal to 2X.
2X.
So, okay, this can also be solved using the general formula that you have. Because if you look at the function like 2x, it is increasing
monotone.
Yeah, it is monotonic.
Monotonically increasing.
Yeah. So that you can also use. But okay, we'll go through this process.
Yeah, this only.
So okay, so we have to find the distribution for y. So for y, if you take less than 0, so y is basically lying between 0 to 4. Okay. For x lying between 0 to 2, y is lying between 0 to 4. Now for y less than equal to 0, what will be fy of y? Right? So that will be equal to 0 because range of y is 0 to 4. So we'll just write 0.
Yeah. Okay.
Now if y lying between 0 to 4, in that case, so probability, what is fy of y? It is probability y less than equal to y, and y is 2x. So 2x is less than equal to y.
Then x is y by 2, right?
All right. So this is nothing but probability x is less than equal to y by 2.
Yes.
And what is fy of y? So this is basically.
Got it. This is okay.
This is okay.
Yeah, this is okay. We have done it.
So you got fy of y to be 1 by
fy.
1 by 4.
Y by 4 I have got it. Next.
So fy of now for y greater than equal to 1, greater than equal to 4, it will be equal to 1.
Yeah, this is also okay.
Okay. So what is
now therefore CDF? How to do a standard method?
Okay.
Here.
So you have found the CDF. Now now you have to go to how to get the CDF. How to get the PDF, right? CDF you got.
Just above. One line above. Yeah. Therefore, CDF of y can be written as this.
Yeah, this is what we have found. No, I mean, for x, y less than equal to 0, it is 0. If for y less than equal to 0, fy of y is 0. For y lying between 0 to 4, your fy of y is y by 4. And for y greater than equal to 4, fy of y is 1. So that is what is written here.
Okay, this is CDF. Okay, what we found above was the CDF. And this CDF can be written like this.
Yeah, right.
Yeah, okay, fine. Yeah, 0 y by 4. Next one.
Okay.
PDF of y can be.
So to find the PDF, you will just have to integrate.
After integrating this f of
differentiate,
y,
right?
Yeah, sorry, differentiate.
After differentiating, this came, right?
Yeah.
Then why otherwise it was less than 0 and greater than 1.
Like say
than 4.
For y lying between 0 to 4, it is y upon 4. So if you differentiate, you will get 1 upon 4. But if for y less than equal to 0, if you differentiate, it is already 0. So if you differentiate, it will be again 0.
If greater than 4, it will also come 0.
Because it is a constant. So it will become out to be 0. So we'll write otherwise it is 0.
Got it, ma'am. Thank you.
Just another way I'm just looking at is consider a uniform distribution of x and y has been defined as just a linear multiplication of that. Then automatically is it okay to say that the resultant distribution of y is uniform 2 times of x?
Yes, that is a general thing.
General way of looking at it only, but this is obviously our approach, the way we have
like how we solve it is a
yeah.
general approach.
Yeah, but had it been y equal to x square, I'm not sure whether we could have confirmed it that way.
Sorry, y I couldn't.
I'm saying that had it been defined as, I think some other.
Yeah, tell.
Hello.
Yeah, right.
Yeah, had it been defined as y is equal to x square, obviously through this method I would have found it out.
Yeah.
But would the general thing work if the original distribution of x is uniform between 0 to 2, y equal to x square or y equal to x cube, whether the resultant would be uniform or not?
That we will
that would depend.
have to check. Yeah.
But as long as it's a linear, obviously I can say that it's a multiplier of whatever is the original one.
Yeah.
Right. Okay, thanks.
Ma'am.
Yeah.
Ma'am, can I ask question from lecture video?
Lecture videos, okay.
Ma'am, lecture 4.7, the last slide.
4.7. I'll go to the slides.
Yes, ma'am.
Okay, tell me. Lecture 4.7.
Ma'am, last slide.
Last the slide. This one you're talking about?
Yes. No, ma'am, not this one. There is a max of x comma 0.
Okay,
something like that.
I think that must be covered in yesterday's session.
Okay, ma'am. Okay.
Yeah, please check.
Okay, I'll yeah.
Yeah.
Sure.
Okay.
Nikita, just a quick clarification in tutorial 1.
Okay.
Tutorial 1, you will have to open the solution, please.
Tutorial 1, okay.
Tutorial 1, question number 2.
Right.
Yeah, question number 2.
Yeah.
So over here, I'm getting the value of k equals to -2.
K equals -2.
Yeah, you can just confirm the solution. Over here, k is equal to 2.
So, all right. So integral from -infinity.
So please look at the third integral, that is given as 1 upon k multiplied by 0 plus 1.
Okay. So if you integrate this, you will k is a constant to come out. So basically it is 1 upon x square. So integration is going to be -1 upon x.
-1 upon x, exactly, correct, right.
So
-1 upon x will be the integration, and then you
you
have
put
the
the
definite
limit from
integral 1 to infinity.
Yeah.
So
What
that
you
will
will
be -1 upon infinity
that is
minus
0.
1, that is 0. So it will be 0 minus 1, right?
You will get, so 1 upon infinity, that is 0, minus
0.
1 upon 1, that is 1. So it is going to be 1.
No, won't it be -1?
No, it will be 1 because this minus term is going to be outside. I mean, 1 upon k, see, 1 upon k is constant, you will pull it out. Okay. Yeah. So in the integral, inside the integral, you just have integral 1 to infinity, 1 upon x squared dx. If you do the integration, you will get -1 upon x.
Okay. Yeah.
So it is a common term. It is common term.
After integration, put the values infinity and 1.
Yeah, so
Not
do the calculations properly.
0 plus 1. Okay, fine. Thank you.
Because power is x to the power minus 2.
Yeah, x to the power minus 2.
Yeah, got it.
First integrate, then put the values.
Thank you, Nikita.
Okay, yeah. Okay, so should we close now? So, did you get the form for the difficult topics yet?
Not yet, I guess.
Not yet? Okay.
What is form for difficult topic?
Okay, no. So you will get a form for the difficult topics from week 1 to 4. So you'll have to fill in the form, like what all topics are facing difficulty in from week 1 to 4, so that it will help in taking the revision session.
Topic is not any topic is not difficult. The difficulty is that the time. With the time.
Okay,
No, it varies from individual to individual.
Yeah, it varies for individual, but averaging we can do.
Yeah.
Because what we are studying is the averaging only.
Okay.
Time is, ma'am, most of the people, I think, if they are professional.
So don't, I mean, even in the exam, don't try to complete everything. I mean, if whatever you know, if you do that much, that should be good enough to at least pass.
Yeah.
Okay, so you will get a form for the difficult topics that you're finding in from week 1 to 4. So once you get it, please fill in the form. On Thursday, 27th, Antu sir is going to take the live session. So it will be helpful.
And the live session timing would be what? In the evening?
It is 7 to 9.
7 to 9. Okay, that helps.
It should be in your calendar. Please check.
Okay, ma'am. Thank you.
Okay.
We'll update.
Mock paper, you will get the mock on either Tuesday or Wednesday.
And what about the 5th week, ma'am? Because we will be busy for the quiz one. Then
5th week is already released.
Released, but I think it becomes every time difficult at the time of quiz.
Yeah, 5th week is.
So now there is quiz 4. There's conceptual understanding. Since there is a quiz 4 scheduled, so are we expected to touch week 5 in between, or it's only after quiz?
So I don't think the deadline for week 5 is going to be before 30th of Jan. So you can, if you are comfortable enough from the from week 1 to 4 topics, you can start from week 5. You can start week 5. Otherwise, you can practice from week 1 to 4 for the exam.
Week 5 is 2nd of February.
2nd of February. Okay, so you have 3 days.
2nd of February.
So maybe
okay.
You can start watching the lectures. If like you, week 5 is quite easy.
It is 6th of February.
6th of February. Okay. I'm not sure.
Is it 6th? If it is 6th, then it is fine. And what will happen for the 6th week?
6th week is refresher week. So whatever topics have been covered from week 1 to 5, you will get a set of questions and you'll take some revision session.
Okay. There is no additional.
No
lectures.
additional content will be given. Yeah.
Okay. That's then it is fine. We will cover it.
Yeah.
First, we have to revise 1 to 4. It is required right now.
Yeah. Right.
Thank you, ma'am.
Yeah. Thank you. Okay. So you can drop off now.
Thank you. Thanks a lot.
Yeah. Thank you. Thank you for joining. Yeah.
Thank you, ma'am.
Thank you.
Thank you very much.
Yeah. Thank you.
Thank you.
Yeah. Thank you all. Yeah.